Mr. Marsden. In our next problem, we'll find the square root. Find the square root of 49. To evaluate the square root of 49, we need to think what number times itself is equal to 49. That value is 7. You know that 7 times 7 is 49. So the square root of 49 is equal to 5.7.
Hi, this is Mr. Rutherford. In this problem, we will learn to find the square root. Negative square root of 4/25. In this problem, we notice we have a square root, and when we have a fraction underneath the square root, we can try to start simplifying this by putting the square root both in the numerator and the denominator of our fraction. So what we have here is negative square root of 4 over square root of 25. Notice that 4 and 25 are both perfect squares. So we have our negative sign out in front. The square root of 4 is 2. And in the denominator, the square root of 25 is 5. This fraction is in simplest form, so we've learned to find the square root.
This is Mrs. Dawson. Use square roots to solve an equation. Algebra. Solve x squared equals 49 over 81. The original equation, x squared equals 49 over 81. And we would like to get x by itself. Using the definition of square root, which is sometimes called the square root property in use, we will take both the positive and negative square root of the other side of the equation. So x is equal to positive or negative square root of 49, which is 7, and the square root of 81, which is 9. Our two solutions are x equals 7/9 or x equals negative 7/9. We can go ahead and check these solutions by squaring both. Our check for this side, if we square both sides, 7 squared is 49, and 9 squared is 81. We're back to the original equation. Squaring both sides of the next equation, squaring a negative gives us a positive. 7 squared is 49, and 9 squared is 81. Both solutions work in the original equation. So x is equal to 7/9, or x is equal to negative 7/9.
This is Mrs. Dawson. The following is a real-world example involving construction. The new gymnasium being built at Summerfield Middle School is a square with an area of 3,600 square feet. What are the dimensions of the gymnasium? Let's begin by drawing a square and noting that in a square, all 4 sides have the same length and each angle is 90 degrees. Since each side has the same length, we label 2 of those sides x. The formula to find the area of a square is area equals side times side, or side squared. We were told in the problem that the area is 3,600 square feet. Let's substitute 3,600 in for area, set it equal to x squared, and then solve for x. By using the square root property, we'll find that x is equal to positive or negative 60. However, because this is a geometry type of problem and x represents length, then the negative value does not hold true in this particular situation. X is equal to 60, so the length of one side of the gym is 60 feet. So the dimensions of the gym are 60 feet by 60 feet.
Welcome to McGraw-Hill Personal Tutors. Find each cube root. Part A, the cube root of 64. Let's remember what it means to find a cube root. If we are looking for a cube root, we are looking for that number which, when multiplied by itself 3 times, will equal 64. With a little bit of trial and error, we see that if we multiply 4 by itself 3 times, 4 times 4 is 16, 16 times 4 is 64, we see that the cube root of 64 is 4. And again, the reason is because 4 cubed is equal to 64. Part B, the cube root of negative 8. Once again, we're looking for the number which, when multiplied by itself 3 times, is a negative 8. Now we know that 2 times 2 times 2 is positive 8. If we make these negative 2's, negative 2 times negative 2 is a positive 4, and a positive 4 times a negative 2 is a negative 8. So for this reason, we know that the cube root of negative 8 is negative 2, because negative 2, the quantity cubed, is equal to negative 8. Thank you for using McGraw-Hill Personal Tutors.